Good morning, everybody, and welcome to today's workshop, a workshop organized by the CEN-CENELEC Sector Forum on PPE that will talk more in particular about standardization for design and use of smart PPE. My name is Els, and I will be moderating the webinar in the background. On the next slide, you will see my picture just to see who I am. And as usual, all the attendees are today muted, so you will not be able to speak out loud at any time, but you have the possibility to leave your questions in the Q&A part of this webinar. The speakers will from time to time have a look at the questions and reply as many questions as possible. Should your question remain unreplied, we intend to make a Q&A report available via the CEN-CENELEC website. So please don't worry, we promise that your answer will be given one day, not today, but as soon as possible. You also have the possibility to tweet about this workshop. We at CEN-CENELEC are on Twitter with the handle @standards4EU, so please feel free to spread the word about this. So I think we can go to the next slide, because on that slide we have the agenda of today. Without going into many details, by the way, this presentation will be shared also with you. We're recording the webinar as well, so you will receive in your inbox as soon as possible the link to the full recording that can be shared with anybody who is interested in smart PPE, and also the complete presentation of today's workshop. So please, I would like to hand over the floor to Henk van Houten, who will be together with me moderating the webinar. Henk is Secretary General of the European Safety Federation. So please, Henk, the floor is yours.
Thank you, Els, and good morning also from my side. So indeed, I'm working for the European Safety Federation, but here I'm also as the chair of the organizing group, being the CEN-CENELEC Sector Forum for Personal Protective Equipment. So welcome to everybody. I see we have close to 120 attendees, which is more or less at this moment half of the people who registered. We had around 240 registrations, which only shows that there is an interest in standardization and standardization for smart PPE and innovative products. So just a short introduction before I give the floor to the first speaker. With the Sector Forum, we started organizing workshops the very first was in September 2017, so almost 5 years ago. And the topic of that workshop was smart PPE and standardization. Now, why do we do that kind of things with the Sector Forum? Well, we believe that one of the roles of the Sector Forum is to make sure that we know what the needs are for standards in the field of PPE, so that we can also share that with the relevant technical committees and working groups, and if necessary, set up or help to set up support liaisons with other groups that have part of the experience that is needed. Because I guess we all know, certainly those who are present here, that you can't be an expert in everything, and especially when you start talking smart PPE, where very often there's electronics involved. You might be an expert in PPE, but not necessarily in electronics, and the other way around. And there's several other fields as well. Now, why did we start with the workshop in 2017? Well, for the simple reason, January 2017, CEN-CENELEC received a standardization request from the Commission to develop standardization documents on smart PPE, specifically garments for heat and flame protection. And that's, we will get a quick overview of that when we talk about the published standards or published documents later this morning. But that was the trigger to bring together people from all stakeholders, manufacturers, test houses, notified bodies, authorities, users, of course, as well, service suppliers, to to discuss, think about what do we need in terms of standards. The advantage in 2017 was that you could do it in person. So we had it live in Brussels. The disadvantage is that when you do it live in Brussels, not everybody is able to travel. So you lose some, or you have a smaller group, let's put it this way. So following that, we had another follow-up workshop in 2019 on the same topic, just to see where were we at that moment. And now in spring 22, we have a third workshop, but this time fully online and not a full day, but only a couple of hours. But to see where are we now, and again, what is still needed, and I'm sure there's still needs, and we'll hear about that later today. Now, with the sector forum, we also we had the positive experience with the workshop on smart PPE, so we thought, well, there's also other subjects that we could look at, and for instance, we had one last year on sustainability and PPE, fully online, where we had even more people participating than today. So again, a topic where there's still a lot of questions and where standardization can play a role. And in October 22, we organized another online workshop, but that time together with the health sector, on products that are at the same time in the PPE legislation and also in the medical device legislation. And as you can guess, that is partly triggered by the experience of the last years with COVID. Okay, so I think that we can slowly move more to the agenda. Maybe one more point that I want to mention at the beginning, and that's after the coffee break, we will have some time for examples from industry, research and development, experiences from any stakeholder. We have a few speakers that have announced themselves in advance. If there is anybody in the audience that is desperate to share some experiences, please let us know, and you will get a few minutes to do so. Maybe another practical thing, you know, in this system, you have a button Q&A on the bottom of your screen. Please use that. If you have questions, put them there. Don't use the chat for that, but put them in the Q&A. The advantage there is that the speakers can, or anybody can possibly respond there immediately, but also that's what we are following for the Q&A parts of the day, of the morning. And I think with that, we have covered the practical points. So I would like to start with the first speaker. Yes, he's online. So it's my pleasure to give the floor to Salvatore Scalzo from the European Commission DG Connect, who will talk about artificial intelligence and what the Commission is doing, has done, and is planning to do. Why artificial intelligence? Well, in previous workshops, we already talked about cybersecurity, about data protection, privacy rules, and so on. And we thought, well, artificial intelligence is also something that is linked to smart PPE, obviously. So it's good also to have a view on what's happening there on the legislative side. So it's my pleasure to give you the floor, Salvatore. And go ahead.
A lot. Good morning, and thanks a lot for the invitation, and I'm very pleased to be there with you today. I will try to provide a brief presentation of the main regulatory development in relation to artificial intelligence at EU level, which is the proposal for a new regulation on artificial intelligence. I prepare some slides, so I understand that the slides, perfect, fantastic, thank you. So next slide, please. So this, first of all, I mean, the background is that the Commission proposed a regulation for artificial intelligence. It is the first effort of such kind worldwide, so of course the challenge was particularly significant. And notably because, and you're certainly aware of that, you are a good, I mean, PPE is a good example of that, but we have also an environment which is also regulated, particularly in the context of product safety legislation. So we had really to try to work to make sure that we could provide a proportionate horizontal artificial intelligence framework which would smoothly interact with the already regulated environments. And I will, of course, then present more in detail the solutions found. But first of all, let's start, no, the previous one still, thank you. But first of all, why do we need to regulate AI? So this is, of course, the essential point that we had to confront with. From the Commission's perspective, we recognize that AI has a great potential for the society as a whole, for citizens, for business, and also for public interest. So we recognize that AI is fundamentally good. At the same time, we also know that AI, due to its specific characteristics, such as a certain level of opacity, autonomy, and predictability, can create some risks, notably to the safety of consumers and users, and also to fundamental rights. And tackling these risks becomes very important also to facilitate the uptake of this technology in the future and to ensure that we can all benefit from the potential of such technology. And in fact, also in the State of the Union already in 2020, the President of the Commission depicted AI as a great world of opportunity, but also pointed out that this world needs specific rules. Next slide, please. Now, what we decided to do when choosing the regulatory model to regulate AI, we opted, and I guess this is particularly good news for the people, like probably the ones today at this meeting, being more familiar with product safety legislation, we decided, in fact, to rely on such very consolidated and to a large extent successful model of product safety legislation. So the typical internal market legislation principles for products, which usually regulate the placing on the market and the putting into service of products. We decided to adopt what is called, and I guess this is very familiar with you, the new legislative framework model. There is a point I want to make on the scope, which is, but I mean, that shouldn't be also a surprise to you, due to reasons of competence, we will, and I will, of course, provide more details later on, but we regulate horizontally AI, but the scope excludes AI developed or used exclusively for military purposes. So due to reasons, of course, of competence and sharing of competence between EU and national level. A second important principle that you have here is that we decided to rely on a risk-based approach. I focused already in my introduction on the concept of proportionality, and this substantiates into a risk-based approach. So to have very targeted measures, but not really to hamper innovation in such an important field. The third key principle is that we want to create a level playing field for EU and non-EU players. So meaning that we want to have similar rules, the same rules, regardless of the location of the operator in question. Next slide, please. When coming to artificial intelligence, of course, and to the scope of the act, which was presented just on the 21st of April of 2021, and I will let you know also later what is the state of play of the discussion. But of course, when coming to the scope, the first important question was, how do we define artificial intelligence? Because actually, if you ask 3 people, notably, you know, in the operators in the sector, but also in academia, they could provide different views of what artificial intelligence is. From our side, we tried to provide a definition of AI which was as neutral as possible, in order also to cover technique which may not be yet known or developed. And we wanted to cover all AI, including traditional symbolic AI, machine learning, but also hybrid systems. And in order to provide the legal certainty, we made sure to include the technique and approaches that should be considered under the scope in an annex to the regulation, which is Annex 1. An important point, this definition that you can see in this slide also relies, with some minor changes, on the OECD definition. So we wanted to create fundamentally a bridge with like-minded partners and build on a definition already quite well established at international level, which is the OECD definition. Next slide, please. Now, I said already, one key principle is the proportionality and the risk-based approach. So what this substantiates in? What does this substantiate in? Basically, it's we identified 4 risk categories. And based on the risk category, some measures are taken. The first risk category is the unacceptable risk. So it's basically practices that shall be prohibited. The second category of risk is the high risk system, which is the real core of this regulation. The third layer is the transparency risk. So AI systems which are not high risk but present specific transparency concerns. And the final risk category is the minimal or no risk. So basically, we don't set for these applications any requirements or obligations. This is an important point because, in fact, the minimal or no risk category, this green layer in the pyramid that you see, includes the largest majority of AI systems on the market. According to our estimation, the high-risk AI systems would be actually expected to cover between 5 and 10% of applications which are on the market. So this shows, in our view, also, let's say, and substantiates that principle of proportionality already referred to. Next slide, please. I will go very quickly on this because I would like to focus on the high risk, which is also more relevant to the PPE discussion. But just for information, so the first layer is unacceptable risk. We want to prohibit practices which contravene EU values. That is the case for AI systems which may provide a subliminal manipulation or exploit vulnerabilities resulting in physical or physiological harm. The same goes for social scoring by public authorities and also real-time remote biometric identification for law enforcement purposes in publicly accessible spaces, though some exceptions are foreseen. Next slide, please. Thank you. Now, the biometric identification, once again, I will try really to go quickly on this. As I said, it is fundamentally prohibited, but there are some exceptions, and those are linked, for example, to certain specific uses which we consider to be important for society. So, for example, the search for victims of crime, the threat to life or physical integrity or terrorism, and serious crime in relation to the EU arrest warrant framework. It is important to say that also under these conditions and when the system could be allowed, there is still a need for an ex-ante authorization by judicial authorities or independent administrative body. And for all other RBI systems that are not subject to prohibition, they are also to be considered high risk. So meaning that they are subject to the requirements that I will explain later on for the high risk systems and a third-party conformity assessment. Next slide, please. Now here I come to the real core of the regulation, the high risk AI systems. What are these high risk AI systems in the AI Act? We try to define them as precisely as possible for the purpose of legal certainty. And we have fundamentally 2 categories. On the one hand, we have the safety components of regulated products. And I will say something in the next slide, but very soon. Or certain AI systems which are products by themselves. So basically, on the one hand, AI systems which are related to products. The second category is other standalone AI systems, so systems which are not related to regulated products and are used in certain specific areas. And you can see here the list of areas that we have considered, from biometric identification, as already mentioned, to management and operation of critical infrastructure, education, employment, access to and enjoyment of essential private and public services, law enforcement, migration, asylum, border control, and administration of justice and democratic processes. You find the full list of use cases in our Annex 3. But I will try now to focus with the next slide on the first category, which is more relevant to you. Here, as I said, we had to confront with the challenge to interact with existing legislation. So what we have tried to do is to rely fundamentally on the risk classification for the product under the sectorial legislation. So basically what happens for these kinds of safety components of products to be high risk, basically the system has to be a safety component of a product or is itself a product. But this second possibility, so being a product by itself, is basically, if I'm not mistaken, it's only the case of medical devices, where a software as a medical device can be a product by itself. Otherwise, for the other, let's say, kinds of products, we fundamentally refer to the safety component of a product. So if the AI system is a safety component of a product, first condition, covered by union harmonization legislation listed in Annex 2, and also the PPE relevant regulation is listed in our Annex 2. And second condition, the product in question is required to undergo a third-party assessment under the union harmonization legislation, then that system would be also high risk for the purpose of the AI Act, and the relevant rules for high-risk systems would apply. So as you could see, we tried really to link our risk classification system to the risk classification of the product under the sectorial legislation. Next slide, please. What happens if a system is high risk? So basically, and I think you are familiar with this concept, we set some so-called essential requirements for the AI systems that the AI systems would be expected to comply. They are basically on training and validation and testing data, so data quality, technical documentation, logging, transparency, information on capability to users, basically, on capabilities and limitations of the system, human oversight, robustness, accuracy, and cybersecurity. And we also require the provider to implement a risk management system in order to detect and minimize all possible risks for the AI system. Next slide, please. You can see also, but once again, I think for people who are familiar with NLF legislation, this is not new. So basically, we have some clear obligations for the providers, which includes the technical documentation, the establishment of a quality management system, a registration into an EU database, but not, I will say something later on, but not for safety components of regulated products, only for the second category of standalone AI systems, and the affixation of the CE marking, a post-market monitoring obligation, and the collaboration with the authorities. On the user side, probably compared to NLF, this is more of a novelty, but we had to introduce some minimum users obligation given the importance of these actors for artificial intelligence. So basically, it's the operation of AI systems with instructions of use, ensure human oversight, monitor the operation for possible risks, inform the provider and distributor about serious incidents or malfunctioning. And having said that, all existing obligations in relation to data processing primarily would continue to apply. So our obligations for users are without prejudice to the ones set in the GDPR. Next slide, please. So here I want to show the life cycle, basically, of the regulatory life cycle that we established through the AI Act. As you can see in the top level, which is the most relevant for you, the safety component of the products, maybe now I must say that probably we are talking about primarily theoretical cases, because I'm not sure that there are already safety components for PPEs, but we can expect in the future this to be possibly more and more common. So it's more of a future-proof concept and regulatory rationale. But basically, if you have a safety component of a product, you can see that not only, as I explained before, the risk classification is based on the risk classification of the product. So, but we also we want to minimize any kind of disruption on the sectorial legislation. So also the conformity assessment that must be carried out for that safety component is the one already existing in the relevant sectorial legislation. So there is no duplication. The requirements of the AI Act for the safety component will be checked as part of the existing conformity assessment system under the sectorial legislation. So it's basically in practice what happens that the real effect of the AI Act for a regulated product is just the application of a few AI dedicated requirements, but there would be no change in terms of conformity assessment in practice, and also on the notified bodies designated, and also on the authorities, because the notifying authority and the market surveillance authority would be the one under the sectorial legislation. And you can see then in this life cycle that there is a registration obligation, but only for the standalone AI system, so the bottom level, as you can see here, the bottom row. And there are some post-market obligations, which are to a large extent not really new for operators that are familiar with NLF. I can mention, of course, this post-market monitoring system for providers, which is important, and it's also related to the changing and evolving nature of AI systems, and a reporting system for serious incidents, which involves providers and indirectly users. And then another thing I want to mention for this slide, just to say that the reassessment, like in product legislation, has to be done if there is a substantial modification to the AI system. But we also set, in order to avoid disproportionate obligations on providers, a system whereby any expected change which would be validated at the initial conformity assessment, and for which solutions would be tested at the initial conformity assessment, in the initial conformity assessment would not be considered substantial modification and would not trigger a new conformity assessment procedure. This is to avoid, of course, that the provider, in the case of AI, would be forced to undergo all the time new conformity assessment. Next slide, and then trying to rush towards the conclusions. So this is just the third and fourth layer, just to give you a flavor of what is in the regulation for that. Transparency obligations. In a nutshell, there are some systems like deepfakes, chatbots. We want the persons exposed to those systems to be fundamentally informed that they are interacting with an AI system. So there are quite minimal obligations, but important to ensure transparency and awareness of people interacting with AI. And the final layer, I already said, we don't set any mandatory obligation or requirement, but we will encourage, together with the future board for AI at the EU level, the drawing up of codes of conduct, which may set inter alia, among other aspects, the voluntary application of requirements for high-risk AI systems for low-risk AI systems. But once again, this will never be mandatory. It will be on a voluntary basis. Next slide, please. And just to conclude with the governance, because this is important, we want to set a European Artificial Intelligence Board composed of national supervisory authorities and the European Data Protection Supervisor. The European Commission would play the role of the Secretariat. This is a place where we would try to work on a harmonized application of the rules across the EU together with the member states. But like in product legislation, the day-by-day application and implementation of the rules would rely on the member states, and of course, including the market surveillance activities and the notified bodies, of course, designation and monitoring. We have also set, in order to coordinate the activities at national level, there should be a national supervisory authorities with the task of coordinating the activities related to the AI Act within that member states in order to facilitate better coordination of activities within each single member state. There is one final note on the timing. We set this proposal in April 2021. So now this is undergoing a negotiation process with the co-legislators. We can't really foresee exactly, I mean, we would need the crystal ball, which we don't have, to know when the act will be adopted, but we can expect, based on progress of work, that the agreement may come and the adoption at some point in 2023. So, in fact, we expect the trilogues between the two institutions, European Parliament and Council, to start very likely at the beginning of next year, and therefore adoption would happen at some point in 2023. From the Commission side, we have set a 2 years transitional period, so meaning 2025 if that period is maintained, but of course the co-legislator may decide to change that. And the final thing, As this is an NLF framework, this will be supported, and today I think this is also an important note, by harmonized standards. And so having harmonized standards for AI becomes essential. We are very pleased with the efforts already undertaken by CEN-CENELEC and in general by the European standardization organizations to already start work on these standards. And in order to facilitate their work and provide them with a solid basis, the Commission already launched the procedure for the standardization mandate on AI already before the adoption of the AI Act, because we want to provide all the necessary and a solid mandate to the standardization organizations to set the technical grounds and infrastructure for building the future harmonized standards to support the AI Act. This concludes my presentation. And once again, thanks a lot for the invitation, and I hope that was clear and helpful. Thank you.
Thank you for your presentation, Salvatore. I think it was very interesting to hear from what's happening on that side, because as you mentioned a few times, there is clearly a link to PPE, and I'm sure some of the smart PPE will definitely make use of artificial intelligence if they don't already do it today. I hope you can stay with us till the coffee break at least, so that we can take questions for you after the next presentations. Okay. What we also foresee during the morning is some polls. So if all goes well, and we do see the first question on the screen, but else, okay, yes, there we go. There's a pop-up on your screen. So please answer to the first question. There will be a few, and we'll look at the results at the end of the morning. So the first question is, should artificial intelligence be allowed to determine protective action of smart PPE? For instance, the amount of cooling to keep a user healthy in a hot environment, but there's many examples that can be given. And you have 4 options to answer. And just to have an idea of how you feel, we added in the reliability of the systems as one of the elements. Okay, so I think we can still leave the poll open a little bit, but in the meantime, already look at the next part of the agenda, and that is, if I can get maybe the next slide already, okay. So based on the standardization requests that I mentioned in the beginning, there's in the meantime 3 documents published. Well, actually, I should say 2 documents published. The third one, the final vote took place, and it was a positive result. So it will be published in the very near future. But to give you an update on what's in those documents and where we stand, we asked the task leaders of the 3 documents to give a brief introduction. So we start with the technical report 17512, which is prepared under the lead of Laurent Houillon, who's working for IFTH and is working on behalf of AFNOR. Unfortunately, he cannot be present with us today, so he asked Karin Oifinger to step in on his behalf. So Karin, if you can introduce briefly. Thank you. And maybe we can close the poll in the meantime. There's still answers coming in. Yeah, we can leave it open. It's still a few minutes.
Yeah, I would suggest to close it in a few seconds, minutes.
Yeah, okay.
Okay.
Karin?
Yes, good morning. Thank you for inviting me to speak. I will be speaking later, and yes, I will try to do my best to summarize the document here that was prepared under the lead of Laurent Hoyon, to which I also participated. So very brief, yeah, the document was already published in 2020. It concerns the additional terms and definitions needed if you have smart garments as personal protective equipment.
Karin, sorry, but would you mind turning on your camera? We cannot see you.
Okay,
there you are. Great, thank you.
So the main topic was heat and flame protection. So the terms and definitions, yeah, are first of all the core terms for smart garments, including electronic garments, and then specifically towards heat and flame, also concerning garments and ensemble of garments. And as was already mentioned by the previous speaker, a good and clear knowledge of terms and definitions is very important to facilitate communication between the different stakeholders, like the individuals in the industry. If I can have the next slide. This was the first document, and it's not going to just be left there. Actually, currently it says many of the terms and definitions are being taken over into the general document EN ISO 11610 for protective clothing vocabulary, which is currently under preparation for the FDIS vote. So that concludes the short summary.
Okay, thank you, Karin, for that brief introduction. So let's go to the second document, which was published last year. And that was developed under the lead of Kalev Kuklane, who's working for the Dutch Institute for Public Safety. So Kalev, please.
Thank you for the introduction. Our institute is supporting the Dutch safety regions with knowledge and logistics. Then, of course, our interest was in such practical guideline related to smart garments. The document was published on 7th of April 2021. The next slide, please. So why this SUCAM document is important? Of course, if we are looking from firefighter perspective, then the exposure at the incident scenarios scenes has changed drastically because of the new materials, lots of plastic in the houses. So the fire is developing much quicker. And of course, in order to meet these new challenges, the new technology is very much necessary in all these different situations. And these new smart textile and clothing solutions, they come in, they start actually that people themselves use their personal equipment, even let's say the heart rate measurement watches, but it's also important that we look how these systems can be integrated in the, our protective clothing to enhance the performance and make the exposures much more safe. Next slide, please. At the same time, it is also that the use of these new technologies has their own risks. In a way, it can be also related to cost taxes. Can we afford it? It can be also overload with unnecessary information. Risks of falling sense of danger. Is our smart system smart enough to handle the situations where battery goes low or whatever else can happen? if I'm relying myself on this equipment, and these risk related to possible system failures, but also risk related to data security. Next slide, please. So this technical report is to assist employers, employees, and suppliers in taking the necessary decisions regarding the selection, use, care, and maintenance of advanced garments for enhanced health, safety, and survival capabilities. But it is also meant that the developers and manufacturers can use it in designing and producing such garments and make sure that when they come on the market, these products will meet the user needs and comply with the requirements set for protective clothing. Next slide, please. So the contents of the technical report, we have the standard chapters, and then of course we cover the general, the total process, and then selection, use, care, and maintenance sections. But in addition to this, we have added also quite extensive part with annexes. So on the background conditions, risk assessments, so that it is possible to do the whole complex evaluation. And then we have also the examples related to practical performance test, how to test it ergonomically. Now I can mention also that there are coming out soon the ergonomic testing of PPE and compatibility testing. One is CEN and the other one is ISO standard. And then it is also maybe important, especially for developers and manufacturers, to think about what are the burn injury risks, what are the descriptions. Next slide, please. And of course, then we have the examples of these scenarios where such incidents can happen. And that would give again a better picture that what are the requirements of those smart solutions that are designed. And also we give the examples of the SUCAM procedures for various smart solutions. Of course, we can't cover the whole span of all possible smart solutions, but here are some ideas what would help to think how I can test my own solution. And in addition, we have quite extensive bibliography to support these finding eventually those tests that fit you but are not described in this technical report. So that concludes my presentation, and thank you for the attention. And here is some information of the coming event next year that our institute is organizing. Thank you.
Thank you, Khaled. And then for the third document, as I mentioned, close to publication, but Karin Oifinger, who was in the lead for the development of this document, will certainly tell us where we stand with this one. Karin?
Yes, good morning again. Indeed, this was a document EN 17673, Protection Against Heat and Flame Requirements and Test Methods for Garments with Integrated Smart Textiles and Non-Textile Elements. The project group was led by myself. Yes, this was a full standard, so it also took a bit longer to prepare it, given the different voting procedures. For one, I want to only very briefly introduce the document here. It, as Henk mentioned, will soon be available for publication. What the scope of the document is, it's applicable for garments and assembly of garments for providing protection against heat and flame, like the other documents as well, with integrated smart textile and non-textile elements for enhanced health, safety, and survival capacities. What was not included is validating claims that the integrated smart textiles and non-textile elements would substitute directly any protection provided by the garment, meaning that the protection is still taken care of by the garment itself. It means that the garment goes through the full screening procedure under the usual standards applicable. So if you can have the next slide, please. First of all, a few examples of smart textile and non-textile elements. These could be parts generated into the protective garment, a device immediately inside the garment, or materials, and also a node which could transmit the data generated or exchanged or exchanges data with external devices. What was not included is evaluation of the data storage or data transmission process, or the external devices where the data is sent to or stored at. I think that will be something for the future, as we already saw on the presentation given on the artificial intelligence, but it was not possible to include it here at the moment. So if I can have the next slide. What was the principle? The document is a supplement for EN ISO 11612 and EN ISO 13688, but does not replace any of the requirements cited in those documents. The idea is that we set the additional testing and performance requirement linked specifically to the integrated smart textile and non-textile elements, specifically towards the functionality of these elements and textiles, and also the efficacy during heat and flame hazards and risks, looking from the electric and electronic safety perspective. So yeah, it's really complementary. Also should assist notified bodies when they get in a smart garment, which they need to test according to the two standards mentioned above, which contain smart textiles and non-textile elements, how to deal with this, how to do the additional evaluation. And then if I can have the next slide, please. I would like to give a bit of an outlook. This document was written specifically for heat and flame protection, but the principles applied in that document could also be used for other risks and hazards. So one could, in principle, write a document for others as well. You first would have to identify what are the standards describing these types of PPE, and then what would the additional testing and performance requirements be linked specifically to integrated smart textiles and non-textile elements. And in the future, that's always the dream for the future. The applications where you would have the protective function replaced, because there has already been research done in this direction. And also the link with external devices and data processing storage. Looking at the presentation we saw from the Commission, this will be very important for the future. And yeah, whatever other applications could come in the future, which we cannot identify yet. So I think that concludes my short presentation. Thank you.
Yes. Thank you, Karin, for that quick overview. So let's now have a look at the standardization projects related to smart PPE that are currently in progress. And we identified two of them. One is in relation to warning clothing with active lighting. And then also in the smart textiles and electronic textiles, there's some things happening that can be of interest for the PPE sector. So next slide, please. Yes, well, let's open in the meantime a second poll question, which is, do we need standards for smart PPE for specific risks? and you will see the detailed question coming on your screen and the possible answers. And while you respond to those, and I can say for the first question, we had 98 responses out of 150 participants. So that's quite good. So I hope we have the same amount for the second question.
For this question, by the way, multiple answers are possible. So people can either choose one option or more than one, just for them to know.
Okay. Thank you, Els, for clarifying that. So don't hesitate to give more than one answer. With that, I want to give the floor to Wolfgang Quetno, who's responsible, or who's the chairing the CEN Technical Committee 162 Working Group 7, which is dealing with high visibility or visibility clothing. And he will talk to us about what they're doing for active lighting. Wolfgang.
Thank you very much. The title Standardization Projects in Progress, that's a bit challenging. To be honest, we started our work yesterday. So I was asked to speak 7 minutes. This will be 1 minute history, 3 minutes high visibility standards, and 4 minutes active lighting. Next slide, please. With the introduction of the PPE Directive in 1989, 3 standards were created to cover the topic of high visibility. The distinction of the 3 standards was at that time the type of use. We had professional use and we had non-professional use. Non-professional use was divided into garments and into the part of accessories. Based on a decision 2013 of the Commission, we changed the distinction of the use from professional use, yes or no, to a differentiation of the risk. So we revised EN 471 to ISO 2471, and the both standards 1150 and 13356 we revised to EN 17353, and EN 17353 was harmonized last year, so we finalized that work. So what is the differentiation of this? Next slide, please. There is a very general rule, and yes, universally accepted, that the probability that a hazard occurs is a risk. And we transformed this definition in high visibility to the risk of not being seen depends on a combination of likelihood and the severity of the event. Next slide, please. Based on this consideration, we established 3 risk levels: high risk, medium risk, low risk. And to give you an idea of what a high risk is, if you have a worker on the German Autobahn every day with high speed, then of course the probability is always, and the hazard is extreme, so this is a high risk. Whereas when you are every 3rd day jogging beside a normal road and do your jogging, then you're doing this occasionally and the risk is low, then you have a medium risk. And what we have done is that we adopted characteristics, properties to each risk class. Next slide, please. So what we have done is that to each risk class, we have given certain characteristics. For instance, as an example, for ISO 2471 for high visibility, we have requirement day and darkness. We have the requirement of 360-degree visibility, designed for shape recognition and circling of the torso, and of course defining quantity and quality for day and darkness. Whereas the different, stop on, And the big differentiation to medium risk is that we here differ, that we can have also day and darkness, but we can have day only and darkness only, that we have 360-degree visibility, and in differentiation, we have here designed for motion recognition and or shape recognition, and of course, definition for quantity and quality for day and darkness. Next slide, please. And now we are coming to active lighting, the topic of today. Together with Dean, a working group developed the technical specification DIN TS 91418. This working group was made of representatives of German statutory accident insurers, institute, road safety experts, textile service companies, manufacturers and suppliers. And the result of this work, of this working group, was published as DIN TS 91418, warning closing with active lighting, in addition to ISO 20471 and EN 1735C. And of course, with the additional equipment for active luminous warning closing, test method and requirements. This work of this working group, of this specification, was handed over to Working Group 7. And of course, Working Group 7 decided to ask here for a new work item. And what I can tell you is that last month, we had the decision that a vast majority of the states decided that we should work on this topic. There was only one member state which voted against this new work item. So what we are doing now is we are starting now this work on active lighting. If you have a look into the scope is active luminous warning closing is designed to ensure that the wearer is conspicuously visible in twilight and darkness, even without an external light source. And that is a big difference. Today, when we are covering requirements for darkness, we are using reflective bands. And as you know, reflective bands are only working if you have a strobe light or a headlight very close to the eyes of the observer. And active lighting is working on its own. You need not a direct source light, a direct light to see the wearer. That is the main difference. So what are now really the main challenges what we have to cover? Next slide, please. So from the perspective safety, we have to cover on one side that we have enough luminosity that a person can be seen, but on the other hand, not to blind somebody or to distract the viewer. So that is really the main challenge we have to cover from the safety point of view. That needs a closer look into it. And yes, this is for me challenge number one. And the second challenge, next slide please, is really in Working Group 7, we are really experts in visibility, in colors, in retroreflective bands, and in road safety. But now with this addition of putting now in electronic components, we are a little bit lost in defining the requirements for electrical safety. And here we have to organize our work with the experts out of this field. And this seems to be a challenge. And if you see, for instance, the list of what requirements need to be covered, I have here some examples. We have a radio equipment directive. We have an electromagnetic compatibility directive. We have a low voltage directive, batteries directive, we have RH, ROH, S2, and so on and so on. And this is a complete new field, and we have to organize our work in a different way. And yes, this is quite challenging to do. So this is my short report on our activity, which started yesterday. Thank you very much.
Thank you, Wolfgang. And now for a bit of an overview of what's happening in smart textiles and electronic textiles. I give the floor to Karin Oifinger once again, now as chair of Working Group 31 within TC248, which is TC248 is textiles and Working Group 1 is smart textiles. Karin, if you can indeed keep to your time, please. Thank you.
I will do my best. Thank you very much for the introduction, Henk. And I have a reply to Wolfgang. There are people out there who can help you, and the Working Group 31 working together with what I will be presenting later, ISO TC 38 Working Group 32 for Smart Textiles and IEC. TC 124 Working Group 2 e-textiles. We have expertise that will be able to help you, and there will be a presentation at our next meeting next week, specifically dealing with measuring the luminosity coming out of LEDs. So the working group CEN-TC 248 Working Group 31, the initial scope was smart textiles. We realized that we had to expand to smart and electronic textiles, because on CEN-CENELEC level, there is no working group really dealing with electronic textiles other than ours. The group was established in 2008. In 2018, we established a counterpart in ISO dealing only with smart textiles. And as already mentioned, we work very closely together with the working group in IEC dealing with e-textiles. As already mentioned before, we worked together with CEN-TC 162 on mandate M553, that was working groups 1 and 2, dealing with terminology and then heat and flame protection. And we are open to cooperate with other working groups on smart textile and electronic textile related topics. So if I can have the next slide, please. Just very briefly, because there's a lot of confusion. 3 circles, smart textiles, wearable devices, electronic textiles. They're not identical, but there's a certain overlap, which I try to demonstrate a bit, that you can have features of everything. If we move on. Smart textiles, electronic textiles, you have some very specific technology involved. The material is flexible and stretchable. Standard electronics is rigid. Also, in a way, the textile is a flexible material in general. Also, other smart materials will be more rigid. As a result, you have different mechanical properties, but on the other hand, you also affect the material's behavior, especially also electronic properties. That can be an advantage. It can also be a disadvantage. If the clothing is, or if it's a garment, you will be wearing it. You have temperature, humidity, closeness to the human skin. You will usually have some kind of maintenance. Again, for wearables, it's washing and cleaning, but also textiles not worn usually undergo some kind of maintenance processes. So if I can have the next slide. They're very specific standardization needs. There's a link between the textile and textile products on the one side, and then smart materials and electronic components and devices on the other side. Smart textiles and electronic textiles are really a category on their own, and it's not just a simple addition of the 2 parts. Even though we try to draw inspirations from both sides, and quite often we end up having to write a specific document where we are dealing with the merger of the 2 fields. Thank you. So what do? We usually identify missing links, what modifications are necessary to existing documents. And quite often we start with, first of all, providing some guidance, because then people can start to address these first before we manage to write some dedicated documents where we're realizing the technology is ready. We also try to do some general smart textiles and electronic textiles testing, which I will give some examples of the documents that have been developed. And we also offer support to product-specific standards development. So in the case, as we already had said, we had the cooperation for the heat and flame protective garments. So next slide, please. So you can find this back in our approach publications. The first document, which is in the meantime a CEN ISO TR. First of all, a bit setting the scope, some definitions, terminology, some categorizations, and how to approach standardization needs. The first document we then wrote was the determination of the linear electrical resistance of conductive tracks. It might seem very simple, but there was no standard available to measure the conductivity of, for example, a yarn, or a fabric where you have a track on it. There was nothing available from cables, for example. The second document was concerning phase change materials. There are standards for determining the heat storage for DSC measurements of polymers, but not for determining heat storage and release capacity of a phase change material. So that was the second document written. Move on, please. We have two more documents. The first is a method for non-contact type resistance measurement of conductive textiles using an eddy current technology, and that was together with ISO. And then, as already mentioned, we cooperated on the standard for the protection against heat and flame for the test methods for garments with integrated smart textiles and non-textile elements. And next slide, please. Under drafting is a specific document, also again, term definitions, categorization, application, and standardization needs for textiles with integrated electronics and ICT. And then next slide, please. So for the future, we would really, for one, increase our international cooperation, and then also increase our support to product CCs. For the moment, we've only had some interest from wearables. And I believe that concludes my presentation.
Okay, thank you, Karin. There is a next question for the polls, which is, or where we link sustainability and smart PPE. So what aspects of sustainability shall standardization of smart PPE take into account? Of course, while ensuring the protection level of the PPE. And again, it's a question with where you can give multiple answers. While doing that, we have foreseen some time for Q&A, and so I suggest I will take those. One question, or the question that I will start with, is one where there is actually already, or also given an answer in writing already, but I would like to mention it, and that's a question. Artificial intelligence is mostly based on algorithm. Data background is mostly 85% male and only 16% female. How will the gender neutrality be taken into account? And I know maybe Salvatore, you have also some comment on that, but I want to share at least that within the CEN-CENELEC community next week, there is a workshop on artificial intelligence, and this topic will be one that will be discussed also there. So if you're really interested in that topic, the link to the workshop is in the answered Q&A, so you can find it there. But maybe Salvatore, you also have something to add on that.
Thank you. But no, in reality, I would have made the reference to the same event, because I think that now, I mean, it is the only element I could add is certainly that the issue of biases is one of the key technical objectives set in the regulation. So in its Article 10, where we have tried also to introduce on the one hand, substantial requirements for data, including, of course, let's say the avoidance of biases, and on the other hand, we also put some data management requirements. So with the hope that, of course, these kinds of problems could be appropriately addressed. I think now that there is a lot of room in standardization to make sure that these expectations can be appropriately substantiated into more concrete and operational technical solutions. And I very much welcome the initiative of CEN-CENELEC together with JRC to devote the topic of this year's workshop to data in AI, including, of course, data biases. So I think that is a kind of work which awaits us over the next few years, notably standardization organizations, to make sure that we can reach appropriate methodologies and solutions to minimize, of course, it can never be zero, but minimize the risk of biases in data.
Okay, thank you for that. I see two questions in the Q&A that are probably somewhat related to each other. Most notified bodies in the PPE sector do not have knowledge on artificial intelligence. This has been so far a bottleneck for certification of innovative products, where indeed there are legislations involved where the PPE notified bodies are not competent for, and then the manufacturer has to look for several notified bodies working independently from each other on the same product, which is for manufacturers not always the best solution. Question there is the Commission working on a solution, on a proposal for that? Because I'm sure it's not only in PPE, I'm sure it's also in other types of products that you have this situation. And actually another question is quite related, I think, where high risk artificial intelligence safety components is linked to assessment by notified body in the product legislation where the artificial intelligence system is embedded. And the question there is, will that not lead to distortion between legislation? Because when a same or a similar system, artificial intelligence system, is integrated in one product, it might be considered as medium or low risk, and the same system combined in another product might be considered as a high risk, which will be a tricky one to deal with as well. So again, Salvatore, sorry, but it's a question for you clearly. Or a few questions for you.
I had seen that in the chat. I mean, there are two very challenging questions, but maybe the first one on the notified body capacities. I think that, no, as you correctly said, Hank, this is certainly a general issue, but does not only relate to notified bodies. I would say that there is in general a lack of skills in the emerging technologies, including AI. So this is something that we have, of course, assessed and which we have to tackle. Now, I believe that this AI Act is also an opportunity to trigger the creation of appropriate skills in the sector, because, of course, it puts the accent on, let's say, on a more clear accent and the more clear expectations at the EU level about building trustworthy AI. So I think that inevitably that there will be an effect. On the other hand, we have a lot of initiatives. So in that sense, I would also mention that the AI Act is the regulatory initiative, but our strategy on AI comprehends also a coordinated plan, which I think is another important point of reference that you should have in mind. It's a coordinated plan on artificial intelligence, which was reviewed in 2021 and published together with the proposal. And then you see that there is a list of important initiatives that we envisage to carry out at either EU level or let's say, at member states level. So it's really a coordinated plan. It's called coordinated because indeed it's basically includes actions that are to be doing either by the Commission or by the member states. And you will see in there that we devote, first of all, a lot of importance to the creation of skills. So this is, I mean, we have several instruments at the EU level, and we will try to push even also through the Digital Europe program initiatives to increase the skills and to create the skills we need. So hopefully that will also help the process. Plus, we are envisaging to create certain testing laboratories at EU level, the so-called testing and experimentation facilities. And we would like, our intention is to make also them accessible not only to the operators, but also to notified bodies. Of course, all these initiatives, I think, I mean, it's difficult to say we will solve this because, I mean, the lack of skills is significant, but I'm sure that this will certainly be helpful to, let's say, to improve the situation and make sure also the notified bodies are fit for purpose by the time the regulation will be applicable, which is not tomorrow, but is not also too far either in time. So as I said at the beginning, we expect something like in more or less 3 years from now for the application of this regulation. So I think we have a not too long period to make sure that, you know, also notified bodies can have and can benefit from the skills that they need. The situation is a bit improved before moving to the second question. I think I've seen, for example, sectors where, you know, AI is already today tested. So I think in that sense, there are notified bodies that have certainly built capacities. I'm coming for medical devices, so my previous experience. And there, you know, despite the fact that there are no AI-specific requirements, still some AI systems are already checked. So I think that there has been a move from notified bodies towards already improving their own capacities internally. I think that with all these initiatives and the AI Act, hopefully, the process can move even further in that respect. On the second question, I want to highlight that, of course, I mean, as far as to the extent I understand this question, but for me, the key point is that our definition of safety component is not about being embedded or not being embedded. So the safety component, if it's a component which exerts a safety function in relation to a product. So contrary to certain product legislation, our definition of safety component does not entail the incorporation. It could be incorporated or not incorporated. What it matters is that that component exerts a safety function in relation to a certain product. So the distinction that I see in the question would not be applicable to our definition of safety component because it is irregardless in our view whether the component is embedded or not. And I think it also makes sense. So I agree with the spirit of the question. So, but it is in fact reflected in my view in our more broad definition of safety component. Thank you.
Thank you, Salvatore. Looking at the next question that is open, if CEN-CENELEC will publish some standards which would possibly be harmonized on artificial intelligence, this means that a product, a PPE, might have to comply with two standards, one under the PPE regulation, one under the artificial intelligence regulation. While this is not uncommon, do you see possibilities that the same requirements could be developed under the PPE product standard? In other words, if I understand the question correctly, that in one standard, both aspects are covered, PPE and artificial intelligence requirements. I don't know, Salvatore, if you can answer that. Otherwise, I think it's a question more on general level to CEN-CENELEC management. Salvatore?
Yeah, I hope you can hear me. No, I can say that from the side, if you look at the standardization request, this is a very pertinent question and one of the key concerns, I would say. But in our standardization request, we have assessed also with the community that the risks of AI are to a large extent horizontal, and also the AI Act is horizontal. So we will look primarily at creating horizontal standards. Of course, if you look at our standardization request, besides this focus on horizontal standards, we say that there should be an assessment also by the standardization organizations where certain vertical specifications will be needed, and it shall be ensured that, of course, when creating any vertical specifications, but also horizontal specifications, there is no contradiction with sector standards which already exist or are in the pipeline. So I see there an important role, of course. I already raised that with the ESOs. I see that a role to make sure that their internal coordination system functions and that there is an appropriate communication between existing sectorial committees and the committees working on AI. So to make sure that everything is built along clear consistency principles. So that is what I would say for the moment. Of course, this is an aspect to be monitored. Now we have launched this request, so I guess we will receive many comments, and we will continue to work with the ESOs also, you know, to support them in planning the relevant activities. But this coordination with sector standards, I think it's really an important need that has to be ensured.
Thank you. And indeed, I fully agree that the integration and the cooperation between different expertise is essential for that kind of products, because you do need the expertise from different sides, and you don't get that, or it's difficult to get everybody together. So cooperation one way or the other is absolutely crucial, and I hope that indeed the standardization system, as well as the Commission and all stakeholders, are moving into that direction, and possibly that will also have an influence on the structure of standardization work in some cases. I think the next questions that I see go a little bit in that same direction, and I'm not sure we will be able to answer all of them now, but it's definitely points that need discussion. There is a more maybe a remark than a question related to indeed also listening to the presentation of Wolfgang on the active lighting. Somebody who mentions, well, he would like to discuss how we can get the expertise in the group requires. I think that the next one is very similar. What is the idea of supporting technical committees for current product groups in interdisciplinary issues as smart PPE, taking into account aspects of ethics, data privacy, ICT, IT, and so on and so on. So the question there is, smart garments seem to be leading the way in this discussion. Any experiences from this group? Yeah, and I guess the last one in the list is a bit going in no, let's not going in the same direction. Let's stick to what I just mentioned. Are there any ideas on that? From my side, I would say yes, we do need further discussion on how to get the expertise in the right groups. But maybe Karin and Wolfgang, you have some experience, or Kalev, maybe you can share your thoughts in a few minutes, because our coffee break is getting very short this way, but interesting questions, so no problem to take them. I don't know if somebody wants to react to that. Wolfgang.
I hope that Karin Euffinger can please explain what a Mode 4 cooperation is. That is a term I'm struggling with at the moment. And that's maybe a way to get experts on board.
Yes, no problem. I've already dealt with it before, but I understand your questions you have, because it took me also a while to figure out what this meant. And there exists something like a Mode 4 cooperation between CEN-TCs. That can be, it's a cooperation that can be established exactly to facilitate the transfer of experts from one working group under one TC to another working group under another TC to work on such overlapping experts. And we had exactly this Mode 4 cooperation under mandate M553. between the textile working group for smart textiles and electronic textiles, and the heat and flame protection in CEN-TC 162, as well as the terminology working group. So this would be a very good option to bring in the missing expert, or to bring together the expertise necessary to develop such a document. I hope that answers the question of the person.
But I guess that's going to be a continued discussion in any case, and probably also in further follow-up of this workshop. But indeed, the cooperation with experts from other fields than PPE is essential, and we need to continue. And I hope that, and I'm sure CCMC is also aware of that, and is also ready to support where necessary and where they can, of course. And I would say we also need experts from Eddy, for instance, the third European standardization body. Being time conscious, I see the last question, and I think I'll give a quick on that. Artificial intelligence in clothing needs electronics to work. How can you ensure the functionality in mechanically rough, extreme cold, and so on? I think that's one, unless Karen is contradicting me, but that's one element that was covered in the standard that is now at the, or in the publication phase, where indeed they were also looking at how do you test the functionality of the electronics in high temperature situations, which is or can be an inspiration to others as well on how to deal with that. I don't know, Karen, if you have anything to add to that.
No, like I said, we took into account the conditions under which the electronics need to stay functional. The standard was pure testing. A different question that is always raised is, of course, can I get such electronic equipment that I can use under such temperatures? But that's a different question. Then you have to go and look at the different electronics available. There's usually a bit more out there than you think there is. And also the temperatures at the position of your electronics are not always the temperatures that are effectively applied from the outside, because you have several layers of clothing. And in the end, at the inner side of the clothing, there's a person which is very temperature sensitive.
Yes. Okay, thank you. And the very last one that I see in the list, but I don't know if we have an answer to that one, to be honest. How is Internet of Things reflected in the build of smart PPE standards as well as artificial intelligence? Or is it defined in the same context? I don't know if anybody has an answer to that one.
Well, maybe I can briefly answer. Is for the moment, we have not taken into account Internet of Things because the smart PPE would just be like a component inside it. So any standards would be related to the Internet of Things themselves. And for the moment, as I said, the PPE is just taken as one of the components that could be in there. We do keep an eye on it, and if necessary, we will look into it, at least from the smart textiles and electronic textiles point of view. And then it can be extended to PPE as well.
Okay, thank you for that. And again, I think it's very important to have experts on that as well in connection with PPE experts. So for the participants that are in that case, please do not hesitate to contact us if you have expertise in the field that you think can be additional to the PPE field. So looking at the time, we are running a bit late, unfortunately, but let's have a short coffee break anyway. So the suggestion is to reconvene in 5 minutes at 11:05. The coffee break is a bit shorter than originally foreseen, but at least we do have time to get a cup of coffee. So see you back in 5 minutes for the second part of the webinar. Thank you.
Test.
We heard you, Boudewijn.
Dank u.
Okay, so 11:05. So let's start with the second part of the workshop. Just a quick reminder, if there are any of the participants that would like to share some experiences in the time slot we foresaw for examples from industry, R&D, or other stakeholders, please let us know, and we can still foresee a few additional ones than to the ones that we have. With that, I would like to give the floor to Marco Meijer from Ricotest, which is a notified body for PPE, where they have already gone through the certification of some innovative PPE. You can question, but all of them, are they smart or not, but at least they are innovative and therefore interesting to listen to their experiences on challenges with certification. And in that case, probably also linked to needs of standards. Marco, I don't know if you have slides prepared.
Hello, Hank. You hear me?
Yes, we can hear you. Go ahead.
No, sorry, I didn't have the time. We are running so fast here. I don't have slides. Okay, no problem. We'll listen to you. So, thank you for inviting me. Well, at the beginning, Hank, I hesitated to come because when I read smart PPE, I think about smartphones, so sensors, data, Internet of Things, artificial intelligence, as we heard today. And we've never had such a product to be certified, as an example. However, in the last period, we have been approached by a company, a manufacturer of airbags for elderly people. So an airbag which is to be worn like a belt, and it detects with different sensors like gyroscopes and accelerators, and of course there is a software with which detects the fall of elderly people, or however people who have problems of walking. And in that case, the certification is not so simple, because all this data acquisition is something new. Obviously, on one side there is already a standard related to motorcycling airbags, which we can use as a technical base, but all the electronic part is something new. Moreover, this device, in order to be ready, needs the user to register his data in the website of the manufacturer. This device also can be coupled with the smartphone of the user via Bluetooth. And when there is a fall, so an inflation of the airbag, the phone will automatically send some messages, or even make a call phone to some emergency number. So this type of PPE is really innovative for us, but it's a mix between something which we already saw many times, because airbags have been certified since almost 10 years in the motorcycling use. But this specific field, so for elderly and the coupling with the smartphone, etc., this is totally new. So generally, we had to take a standard which is already issued and add some internal methods. From this, I would like to split to another product that we certified, which is not so smart, because it does not have anything about electronic, etc. It's a so-called exoskeleton. So it's a device which has to be worn like almost a jacket, because there is a sleeveless vest with a zipper closure and waist belt, and all the other hard components with some gas springs, which gives an elastic response in case of bending forward of the torso. Well, all this is almost mechanical, but it's completely innovative. In the last years, many exoskeletons have been proposed to the market in the last couple of years in particular. And at that time, when the application was requested to the notified body, it was the first time that we received such a request. But as a notified body, we cannot priorly saying if that such an innovative product cannot be certified. So there is still an ongoing discussion if the exoskeleton has to be considered as PPE or not. But in the meantime, the market is pushing on this and in this field. There are many products of this type. Probably they are just sold. There are many kinds of exoskeletons, passive or active, which means with additional engine, sensor, actuators. And in this case, it's really a basic exoskeleton. So we evaluated the proposal of the manufacturer, who sent a lot of technical documentation, studies, thesis, I would say, and we added information which we gained from university, from different studies which we which we found. So in the end, we just took for granted many of the documentation that we received from the manufacturer, and then we had just to study the mechanism for which how this device works, and we studied a lot of statistics. Let's remember that the musculoskeletal disease is the first problem for workers, both in Europe and in the US, and in particular for the back lumbar area. And this device was designed specifically for the prevention of such disease. There are some problems, in my opinion, because the risk listed in Annex 2 of the regulations are not directly linked to the risk categories listed by the NANDO, for example, and which are also the same, which are used for the accreditation of the notified body. And in this sense, there are some unmatching categories. By the way, for this specific exoskeleton, we applied the categories of the compression, risk of compression, because the main problem related to the back lumbar disease are related to the compression of the disc between the vertebrae. Just think that a normal person standing up could load like 70 kilo on the disc, and by bending forward, the weight the load on the disc rise up to 500 kilos. So having an external device which gives an elastic response and which decreases this load on the disc, of course, is something that helps to prevent the back and lumbar pain. The challenge on this kind of innovative product is the fact that since there is no harmonized standard, the notified body has to, let's say, invent a dedicated technical protocol. And it is not always to be thought that everything is to be quantitative, even qualitative. So, for example, for this specific case, we made practical assessment with many people, and every people had to do some specific things. And everybody has to make a judgment of the feeling. So, of course, the more people we have, the better is the result. But it's not everything black and white, and this can lead to discussion with authorities and to other stakeholders. But even for exoskeletons, there is a large literature, and for the musculoskeletal disease, There are even, in this case, a large number of studies and data coming from the health and work institution. So we feel quite confident that in the future there will be some additional categories of risk added to the notification system. So that was my point of view on this situation.
Thank you, Marco, for your contribution and clearly indicating that certification of innovative products, whether they're smart or not, is causing some challenges. And I'm sure if there would be standards available that would make life easier. Of course, you cannot develop standards if there's no experience and knowledge available. So that's the other part that is also necessary. So there definitely needs to be an exchange between all concerned parties. With that, I would like to go to the next block of this workshop, which means that we're going to listen to some presentations from various stakeholders. And again, if there are participants that want to add something, please let us know. But the first one we're looking at is from Werner Groms from the German Social Accident Insurance, IFA, and he will talk to us a few minutes on safety critical aspects of illuminated workwear and wearables. And if I see his, yep, your presentation is ready. Go ahead, Werner.
Okay, first, good noon to all. And now I can start with my short presentation with 3 slides. Okay, we see on the left side the clauses we tested for the illumination, because the illumination is very important. We have glare effects, and also we should see the illumination in long distance, around 50 up to 150 meters. And we did a lot of tests, and also in the night with probans. I can show you now short results and the risks. And we have a lot of risks here detected in our vests and jackets or caps and so on. And what we have seen is that we need long range in the darkness. And we could see also strong glare effects in 1 meter distance. Another point is electromagnetic compatibility. We have seen that a lot of illumination vests on the market with electroluminescence, and this means that illuminating is built with high voltage in the range of 300 volts. And then we have seen that all the vests and jackets, clauses, and so on will work with USB power banks, and there is integrated lithium-ion batteries or lithium polymer batteries. And we cannot find there that it is tested, and there is only we cannot see a test certificate. And this is safety critical. One back, yes, safety critical is if we have a short in the wiring, and the harness is also very important kind of safety, then we can see that lithium batteries will blowing up and can explode. And the problem is we have now this battery very closely to the human body. And also the cable harness is very important. If there is a short inside, we can have these explosions or these fire problems and so on. Go please to the next slide. So we were starting with luminance measurements. We need for that special measurement tools. And we have seen there crazy values with, on the left side, 18 kilocandela per square meter. It's very strong, up to 78. And also we have here seen the yellow head mask with a very strong glare of 2 millions of candela per square meter. So if you look inside these LEDs in a distance of 1-2 meters, you will see nothing. You will see only black, and this is absolutely not acceptable. If you are driving on your bike and you have this on your head, you can blend, you can glare all the drivers on the road and so on. Then we have looking for the wiring of the batteries. And we could see that are the black-white pictures that we could detect that the battery is very strong to put in the jacket. And if you change now about 5 or 10 times the battery for charging out, then you can see all the wires will be free and not inside the jacket. And this is then a problem. If you do it then more, 10 times, 20 or more, then you can make hair short, and the short will produce a problem to the battery. And you can see on the right side the first camera systems we used for measuring the luminance. And now on the right side, on the top, on the bottom, you can see our new built measure lab, photometrical measure lab. So we can do professional in a dark room, all measurements with calibrated equipment. Going to the next slide, please. Then we found on the market vests or equipment with lightning products inside, and it is not clear in the documentation, is it a LED or is it electroluminescence? And the craziness of electroluminescence is they use a 3-volt battery. This is okay, and could see, yes, it could be safety, but this 3-volt battery will get with a high voltage transformer, a voltage around 370 volt peak to peak, and all the lightning here, the surfaces here, and also the wiring to that will have a very strong high voltage. And also we could see that these surfaces or this electroluminescence variables will produce strong magnetic fields and electric fields. And this is a problem for the pacemakers. If the pacemaker is closely with the lead to these surfaces or to this transformer here, then we can have the effects that the pacemaker can be destroyed, or the pacemaker will go in the safety mode and is switching off. And for this, we did all the measurements here with a probe. So you can see the red ball is a measure instrument, and we get there isotropic values of the magnetic field and also of the electric field. Then we found a T-shirt, and this T-shirt here is also produced with electroluminescence, and we could measure there also a field strength around 1 kilovolt per meter, and the harmonic overtones were going up to 40 kilohertz. And you can see the place of the heart here is also closely to the human heart. And there is placed the lead of the pacemaker. And this could be also negative effects. So this is my end. Yes, okay. You have questions about it?
Thank you, Werner. We will keep the questions to the end of the morning session so that we take all of them at the same time. So thank you for your experiences, and I think clearly shows that there is work to do, and I'm sure you're working with the group within the standardization on active lighting and bringing your information and your experiences into that group as well.
Okay, thank you.
Thank you. So with that, I would like to give the floor to Boudewijn Wisse, who is the Chief Technical Officer and one of the founders of company Laevo, which happens to be a producer of exoskeletons. So let's listen to his experiences from his side with the PPE legislation and lack of standards. Boudewijn.
Thank you, Henk, for your kind introduction. And also thank you, Marco Meyer, for your explanation of how difficult it is to certify an innovative product when there are no standards available. My name is Boudewijn Wisse. I'm the CTO of Laevo Exoskeletons, and we have been selling exoskeletons for 7 years now as a medical device. And we recently launched a new product, the Laevo Flex, and we've certified them as a PPE. So the Laevo Flex, I don't know if you can see my background, but it's shown there, is a wearable device that protects workers against work-related back injuries. And it's used mainly in logistics, manufacturing, and other sectors such as healthcare for people to stay healthy when they do physically demanding jobs such as order picking. Exoskeletons are an innovative type of device, and they can be viewed in many different ways. So they can be seen as a medical device if they are intended for patients to be used by back pain patients. They can be seen as a machine when they're intended to take over the work of the worker, or they can be seen as a PPE when they are intended to be used by the workers to maintain healthy and safe. And maybe they are all at the same time. So choosing which is the intended use of the product really defines also the legal framework that you need to comply to. Our exoskeleton, as it is a mechanical device, so it doesn't have any motors. And for these kinds of exoskeletons, there are no harmonized standards available. However, we see that exoskeletons are in the future will be augmented with sensors, because it's very logical to put sensors in either to do active control or to monitor the movements that are being made by the user. So there are competitive products from the Laevo Flex that do have the same functionality, but integrate sensors and other smart applications. So we think it's really, really important that we've got this opportunity to certify the product as a PPE, because in our experience, companies that buy them, workers that use them, view the device as a PPE. They treat it as an PPE in the workplace. Also, we never encourage people to start lifting more, doing more job because they are stronger with our product, but really use it to decrease the injuries, the risk on injury. And last but not least, the product should only be used where there is this elevated risk on injury. So it's very important which kind of choice we make and which kind of certification and intended use we're looking for. Because the PPE as a preventive measure is lower in the hierarchy of control than, for example, engineering controls or automation. And it also makes a big difference, of course, for us as a company, what kind of processes we need to do internally. So we've come to this discussion and this conclusion after many years of working in the field, working together with customers, but also talking to notified bodies, going to occupational safety and health conferences. And we were very happy to find a partner that was able and willing to take this step and really certify it as a PPE. Of course, we also keep a lot of good practices as a company, having our quality management system running, doing our standard operation procedures, et cetera, so we're really confident that we are making a safe and reliable PPE. We think that for many smart exoskeletons, will follow the same route in the near future, and that you will see smart PPE exoskeletons in the market. Thank you.
Thank you, Boudewijn, for that point of view. I see several questions, so we will have some time at the end to answer those. So I hope that Marco and Boudewijn and Werner, you can still stay with us a little bit longer till around the end of the workshop at least. So with that, I think we have a next poll question now. Yes. Simple question. What do you consider as smart PPE? There are some definitions, but it's also interesting to see what you think that would, and again, you have the possibility to give more than one answer in the poll. If I can now move to the last, I'm not saying the last presentation, but the last topic. If you can go to the next slide. Yes. So we thought it was also interesting to have an idea what is happening outside Europe in standardization of smart PPE. And for that, we asked Karin to have a look at what's happening at ISO and IEC. And Sarah Gobi, who's representing ASTM International in Europe, will give us some information on what ASTM is doing in that respect. So Karin, your 5 minutes start.
Thank you. I'll maybe keep it a bit short. Sorry for the video. Developments in ISO and IEC, I already mentioned briefly. There's two groups. We have ISO TC 38 Working Group 32, Smart Textiles, which is also convened by me. And then we have IEC TC 124 Working Group 2 E-Textiles, which I am attending as liaison from ISO TC 38. Also, since it was mentioned before, we have a mode 4 cooperation between the two groups so that we can exchange experts. I made a small diagram to show a bit the interactions. If you can go back, sorry. You can see that there's a Vienna agreement between CEN and ISO, and the mode 4 cooperation between ISO and IEC. But between CEN and IEC, there's a bit of an indirect link. We go via the ISO route. So, but it's the same. It's a lot of there are a lot of experts which are attending all three groups, so that we have a strong representation. So if we can move on. Smart ISO TC 38 Working Group 32 is still focusing on smart textiles. The primary focus is really the textile properties. But we look at textiles for smart and also electronic applications, some general guidance and modified test methods for textiles with smart and electronic properties. What are some additional features one would have to look into? If you go to the next slide, these are two publications. The one, as I mentioned, is under publication, and the other one is also the ISO TR. Those two documents were mentioned before. Can you move on, please? And there's 2 documents under development. The one is to determine the heating performance of thermal clothing with an integrated heating device, which is of interest, I think, for cold protective clothing. And the next one is to determine the screen touch property, basically gloves you use for operating a touch screen. Next, please. ICTC 124 Working Group 2 is focusing on e-textiles. They focus on the electronic properties of the textiles, what type of materials can you use, and the focus from the TC is wearables, so they're focusing also on the wearable products. So we can go to the next slide, please. Too much. They already have several publications, also again, some basic measurements, and they look under the simulated microclimates for wearing and close to the body, and some washing specifically for e-textiles, and also connectors. The snap fastener connectors are also quite an important issue. And next, please. Then there's some documents under development for the abrasion resistance. They're revising the document for washability already. And then the next one is knee and elbow bending, which is a quite important feature of wearables. Next, please. And then there are some preliminary work items which are under preparation and then coming into the pipeline. And these are specific for components. The one is for piezoelectric energy, for making energy, and also some stress management and some specific sensors. So next, please. No, back one more, sorry. Because that's already the next. I would like to mention, because the question was raised before, is there any cooperation with other groups? Yes, in ISO TC 38 Working Group 32, we have a liaison with ASTM. We have a liaison with AATCC, so that there is an expert presenting always an update from that group. And we have some of our experts are participating in the work of IPC. So they also regularly give an update on what is going on there and can also feedback to them as well. So we have maybe not always a direct cooperation, but we always have experts who can provide updates. And that concludes my presentation. Thank you.
Thank you. Thank you, Karen. And then you mentioned ASTM, so perfect bridge to Sarah, who will give us an update on what ASTM is doing in this field. Sarah, the floor is yours.
Hello, everyone. Can you hear me?
Yes, everything fine. Go ahead.
Okay, great. Yeah, so I will give you a very brief intro about ASTM for those of you who are not familiar with the organization. It's a very large global standard setting organization. We are developing international standards and testing programs. We have over 150 technical committees, so our scope is very broad and comparable to CEN or ISO scope. And our process is very flexible and agile thanks to the direct membership model. So everyone, every technical expert with an interest in a particular standard, in particular topic, can join our technical committees. We currently have 34,000 technical experts that are members of our committees around the world. You can go to the next slide, please. I just wanted to highlight some of the activities that are currently underway within some of our technical committees, and in particular, and of course, if you have any questions or want to learn more about those, just be in touch, and I will make sure that I will put you in touch with our experts and our staff in charge for those. So our D13, our committee D13 on textiles and Subcommittee D1350 on smart textiles, which, by the way, is meeting next week, is meeting in Seattle on the 13th of June. And there will be also virtual capability. So if anyone is interested in joining, just let me know and I will put you in touch with the organizers. They are looking to update and revise the scope, so to coordinate with AATCC RA111 and to avoid duplication of efforts. And they currently have one published standard, which is the 8248 terminology for smart textiles. And there are 2 standards underway, 2 work items that will look at the durability of smart garment textiles exposed to perspiration and after laundering. So despite commercial examples of those products, there is currently no standardized test methods to evaluate the durability of such smart textiles in certain conditions of use, and the standards will look at those specific properties and requirements. And then, so as I said, the AATCC group, which is the American Association of Textiles Chemists and Colorists, their group RA111, it's Electronically Integrated Textiles, which was formed in 2016, and it's developing methods and terminology for the testing of electronically integrated textiles. They work in coordination with Astm, and as Karin mentioned, also in coordination with ISO. Another area that I wanted to highlight is our technical committee D15 and the subcommittee 1575 on connected products. That was created in April 2019, and they developed a standard guide on the safety of connected consumer products, including wearable, connected health trackers, and smart apparel. And the focus of this standard is limited to consumer products, and specifically to the physical safety hazards created by a product's connectivity. The guide was published in 2020 and just revised last year. And last but not least, and I was happy to hear from previous speakers about the importance of exoskeletons and exotechnologies and their interface with PPE, because ASTM, in fact, has a technical committee on exotechnologies, F48, exoskeletons and exotechnologies, and we also created a center of excellence with the other partners to really bridge the gap between innovation and standardization in this area. And so the Exo Technology Center of Excellence is expecting to put out this year some available funds to support projects, research to standards projects. And one of the potential areas that we will be funding is the interface between exoskeletons and PPE. So I would be happy to keep you posted about that if anyone is interested in those projects, in participating in the call, I mean. And then the other thing that I wanted to mention is that the Center of Excellence is also planning a workshop in 2023. And we are planning to put on the agenda the topic of exoskeletons as used as a personal protective equipment. So if anyone from CEN or the previous speakers is interested in this topic and would like to participate as a speaker in the workshop, just be in touch, and I will be in contact with my colleagues. And with that, I'm good. I'm done. Hopefully on time. And thank you again for this opportunity.
Thank you, Sarah. Certainly interesting to see that there's also things happening in other parts of the world. And I would say concerning this workshop on exoskeletons, if you can, if the dates and so on are fixed, if you can inform us at the PPE Sector Forum within CEN-CENELEC, we will certainly share that information in our community as well. With that, we are at the discussion Q&A of the last part, and we're still running a little bit late. So let's launch the last poll question. Does the market need standards for smart or innovative PPE? And there you can only give one answer. There's a few yes possibilities, and there's also a no possibility. So if you can have a look at that one quickly while I'm going to go through the questions. I think there's a few questions, comments that are related to the issue, is an exoskeleton PPE or not? I can share with you that at the PPE expert group, which is organized by the European Commission and the members or the member states, as well as representatives of European stakeholders, like notified bodies, like CEN-CENELEC, like my organization, but also other organizations representing parts of the market. There is discussion ongoing on exoskeletons, but I think there we have the same issue as for smart PPE. What do we mean with a smart, with an exoskeleton? There's many different functionalities and applications. So to give a yes/no answer on that question is virtually impossible, but it's an ongoing discussion. So I would say I don't think it's relevant to go deeper in that here at this moment. The same that indeed there is a question or a remark, maybe even that, yeah, for the notified bodies classification in the NANDO database, for instance, maybe we do need indeed a category or more categories to fit smart PPE in there. That is another topic that can be further explored for sure. Then I see, are there notified bodies available who have competence to certify smart PPE? Not only speaking of complex artificial intelligence or electronics, but indeed this seems to be a real existing bottleneck for placing new smart products on the market. And a manufacturer must be able to find notified bodies who are able to do the certification, which is not always the case. And yeah, then specifying more into the competence to assess electronic parts. And I think we've heard also further during the morning the examples also in the active lighting, and the conclusion of the topic is without standards it will be very hard, and I fully agree on that, and that's also why we're sitting together this morning to see where the gaps are and what can be done. So so I don't know if there's any comment from any of the speakers on that statement question. I would say the next one is very much linked indeed, that what we've heard, the examples show that smart PPE is not only covering or not only dealt with in the PPE regulation, but also others, and that for notified bodies in the field of PPE are not necessarily competent or even trying to be competent on other legislation. Which only complicates life. So yes, we do need a some structures for that. There's also a remark related to that, for such products, the quality of the technical documentation from the manufacturer is sometimes a problem. So, which again, I would say, if there's a lack of standards, it makes life for everybody very difficult. One, for the manufacturer to know what to use and how to prove that his product is compliant, but also for the notified body on what are the requirements and how to check the requirements and the statements of the manufacturer. So it only increases or shows the need for standardization work to make sure that everybody can work in a harmonized way. There's a remark, again, as I mentioned, related to exoskeletons being PPE or not. And then there is a fundamental question that I certainly agree with having the question on the table. Not sure that we will have an answer to. Well, I'm sure we will not have an answer now, but it's something to look on. Certainly, also on a political level. And the question is, why is there no coordination worldwide? There are lots of organizations dealing with standardization, especially also in that field, CEN, ISO, ASTM, IEEE, IPC, AATCC, you forgot IEC in the list, ETSI, and so on and so on. I'm sure we can find lots of others still. It's confusing, yes, of course. Why not consolidate? And I would fully suggest that kind of efforts, especially in innovative products. It's not helpful for the market to, if there's no consolidation, it's already difficult to find experts. So why not share and consolidate? And I can only applaud that there is at least attempts with liaisons between different organizations. And there is a comment, the last comment I see is that indeed there are several legal frameworks, also globally, of course. We have, for instance, our PPE legislation in Europe, which is non-existing in, for instance, the United States or Canada or Australia or wherever. So that's another aspect, of course, that also plays a role in the standardization. I see there's a hand raised from, I think, one of the panelists. Or is that a mistake from my side?
No, it's the hand of Mr. Henrik Wallstedt. I see.
Okay.
Shall I
then
unmute
can
him?
we give him
the
floor, maybe?
Let's see. Oh, no, his hand is down again. I don't know if that was a mistake. But there's another hand now. Khalif wants to say something. Khalif?
Yes, I put it in the chat because panelists are not allowed to put it in questions answers. That actually it's a question to Marco, that they have developed very many new test methods to test these innovative products. So then the question is, can these testing methods be available for standardization bodies to be included in the testing standards of smart devices? Thank you.
Okay, Marco, do you want to respond to that? Marco, you're muted. Yeah, there we go.
Sorry, Hank. I was reading all the questions. I lost the last one. What? Can you repeat it?
Sorry. The question Kalev put, and I think it's a very valid question, is that, well, you used several methods to evaluate the exoskeleton, but maybe also other products like the also the airbags you mentioned, where there is partly that you can use an existing standard, but not everything. Is that something that knowledge, is that something that can be shared with standardization groups so that it can be taken into account when developing standards? And I think that's a very valid and important question, and maybe not even a question, but more an appeal to do so, to be able to develop standards that make life of everybody easier in the future. But maybe you have a different view on that.
Yeah, we can share our knowledge. I don't want to take the part of the big expert, because really we are not big expert. There are for sure people who studied exoskeletons since more than 15 years probably. But yeah, we went deeply into this, and yeah, we have our internal methods. We have both a lot of standards even from the machinery directive and from the medical device. We just group a lot of methods which came from already existing standards, and then we studied a lot of the technical documentation, which luckily was quite complete. Was quite well done by the manufacturer in this case, which is not always like that. But yeah, I've been personally also contacted by Astm, American standard, and they have also dedicated technical committee for exoskeleton, and they are interested in developing standards as well.
Okay, thank you for that. Looking at the time, we're running a little bit out of time. I just want to read the final comments in the Q&A, which is in the UK, we're looking at what agile standards may bring to bridge any initial gaps. And they see smart PPE can be defined potentially as PPE with data. The real issue for innovators is also funding, and I agree with that. Without assurance, it is very hard to find. So without assurance, there is no potential innovation. So basically, I understand that also that, well, to get the assurance, you need also standards to be able to prove. So it's all very much linked together, of course, and it only proves the importance of working on standardization on that. Conclusions of this morning. Well, first of all, clear that there is an interest in the topic. Also looking at the number of participants. At some point, we were with more than 160 participants. So it's clear there is a need to continue to work. Thank you, Inga, for putting the poll results quickly on the screen. So just also there, first question, should artificial intelligence be allowed to determine protective action of smart PPE? For instance, the amount of cooling necessary to keep the user healthy in a hot environment. That was a single choice question, and well, the majority is clear for yes. There's only 7% that answered no. But also there you see the difference. Only 20% said yes without any conditions, 27 is happy with 90% of reliability, but 46% is clearly looking for 99% of reliability. So that's clearly a point to take into account when going for smart PPE and artificial intelligence. It's not only the presence, but also the reliability is an important issue. The second question, do we need standards for smart PPE for specific risks? That was a multiple choice question. There we see a more divided response, probably. Certainly, the votes for separate standards for each type of smart PPE and general standards with a risk-based approach, like for chemical risks and so on, are equal, and some less for general standards per sector or general standards for all or most types of PPE. Question 3, aspects of sustainability that should be taken into account when looking at smart PPE. Repairability, maintenance, washing clearly gets a lot of votes, which makes sense, I would assume. Modular design, the same, 59%, so clearly an aspect that needs to be taken into account. Recycling, repurpose, more or less the same number. Biodegradability, a quarter of the votes, and efficient use of resources, again, more than 50%, which only shows, and no sustainability aspects, only 4%. So that clearly shows that whatever we do in standardization, we need to consider sustainability, and not only one aspect, but several aspects of sustainability. What do you consider as smart PPE? Again, a multiple choice question. For some reason, all of a sudden in German now, the comments. Any PPE with electronics included gets 40% more or less. PPE where the protective action is triggered automatically, for instance, by using sensors and so on, that gets 2/3. Phase-changing materials, for instance, for shock absorption, color change in certain situations, and so on, that gets more than 40%. All of the above, also 23. So for me, that shows that there's still some different views on what smart PPE are, which only proves the need for clear definitions of smart PPE. And I would suggest do have a look at the technical report 17512, which does include a definition for smart PPE or smart protective systems. I think that's a good start, but definitely maybe worth some further discussion even. Next question that was asked, does the market need standards for smart or innovative PPE? And what would be the most successful? And there only one answer possible, where not at all, no answer, nobody is convinced of that. So that's a good thing. A few percent say yes on national level, then 40% yes on European, and close to 60% on international, which only proves again the importance of working together on international level so that we can come to joint standardization. With that, I think we have many ideas again for future work. We will definitely, with the sector forum, carefully consider all the comments, questions that were asked, those that were not yet answered or not completely. We will try to answer them in the summary of the day. But definitely there's work to do, and I think indeed, and Sarah, you already mentioned also the willingness to work together and see, I think indeed it's important that we know from each other what we are doing so that we don't duplicate the work. One in a field where there's lots of novelty, it's difficult to find experts. So if you have to divide them and part of the experts work on this and a part in another organization, that's not really helpful. That's one. And second, for the market, for all concerned, if there are standards that are the same all over the world, it also opens the door for the market a lot easier than if you have to comply to different standards in different parts of the world. With that, I would like to thank all the speakers of this morning for their very valuable contributions, and I hope we can continue to work together with all of you. I would also like to thank for sure the people behind the screen, you could say. Well, else you have seen in the beginning, and you've heard her a couple of times. So thank you, Els, and your team at CCMC, but also Jennifer, who's our project manager dealing with PPE at CCMC. I know you've also done quite a lot of work in the background. And certainly also Inga Truster. You didn't hear or see her this morning. There she is, working at DIN. And she's the secretary of the PPE Sector Forum. And I can assure you, without those people in the background, there's no way we would have been able to organize this workshop. So thank you very much to all of you. And I hope we can do this again at some time in the future. So, thank you very much also for the participants for your contributions and questions. And if there is anything further that you want to share or ask, please do not hesitate to contact the Sector Forum. As I mentioned in the beginning, we want to know what's necessary and needed for future standardization work. And with that, I would like to close the workshop for this morning and hope to see you again in the future events. Thank you.